Welcome to the Calsoft podcast series. This is your host Mark Rodrigues. With me today, I have Saptak Takalkar, who's going to be talking about DevOps essentials, infrastructure as code. Hi, Saptak.
Hey, hi, Mark.
Hey, it's good to have you on the show.
Thank you so much. How are you doing?
I'm well, thanks. Interesting topic today?
Yes, definitely. I'm looking forward to this podcast.
Brilliant. So before we get into the podcast, I'm going to quickly introduce Saptak. He's a DevOps evangelist here with us at Calsoft. He's a graduate from the University of Texas at Dallas. He's done his MS in computer science, and he has experience working in the past in the cloud and the healthcare domains. So right now, he's working with us on different DevOps and OpenStack projects here at Calsoft, and he's involved in a huge DevOps project or R&D that we're doing at the moment. So once again, Saptak, it's great to have you on the show.
Thank you so much, Mark.
Saptak, we've been hearing about DevOps quite a bit in today's technology, and everyone's talking about it. Can you throw some light on DevOps and what are different DevOps practices?
And definitely. So, Mark, before I explain what DevOps is, let me first tell you how development and operation team work traditionally. Usually what happens is development team will create a package or a solution they want to get to the production.
Right.
And they will hand it over to the operations team.
Right.
Operations team will then start preparing to put that into the production.
Right.
They will manually change configuration files, create or change the environment in production appropriate for which they wanted to deploy.
Mm-hmm.
Eventually there is a lot of duplication involved in what development and QA team had to do and what operation team was doing. A lot of times there are issues and they run into problems, the bugs which did not get caught before. So in this scenario, the development team gets called in, but they say, hey, it was working fine in our environment. Now it is not working in production. So it must be the operations team's problem. They must have misconfigured something.
Right.
Operation team says that you gave us something that didn't work in production. So it must be your problem.
Right.
So there is always this kind of a confusion between the teams that are involved in the software delivery and infrastructure changes.
So basically you're just handing over or you're blaming one another.
Yes. Yeah.
Okay.
Yeah. So this is not DevOps basically. So can we improve and kind of get rid of this confusion? So definitely we can do that using DevOps. So DevOps is a culture or a movement that emphasizes the collaboration and communication of software developers and other IT teams while automating the process of software delivery and infrastructure changes. There are many different practices involved in DevOps. So we have infrastructure as code, continuous integration, continuous deployment, load testing and auto scale, app performance monitoring, and so on. Since it's very difficult to talk about each of these DevOps practices in detail in one podcast, I think we are going to concentrate on infrastructure as code today.
Absolutely. In fact, if you remember, Saptak, we've already tackled continuous integration and a couple of these other in our earlier podcast series.
Sure, yeah.
Okay, so now, as you said, focusing on today's topic, infrastructure as code. Sounds fancy. What is it?
Sure. So first, let me tell you a situation which will basically explain why we need infrastructure as a code.
Right.
Suppose you receive this notification that one of your server is unreachable.
Correct.
You follow your usual quick fix routines only to find out that server has actually crashed.
Okay.
You then try to recall every steps you had taken to configure that server along with the components installed and their versions.
Right.
And maybe you do have a documentation which will basically outlines every step to reconfigure everything. But consider the time you need to invest in order to accomplish your task manually. So do you think, Mark, we can do this in a better way?
Absolutely.
Definitely, we can do it. So how can we do this? By describing and managing your infrastructure as a code. So Mark, infrastructure as code is one of the essential practices of DevOps. Infrastructure as a code means writing code to manage configuration and automate provisioning of infrastructure in addition to deployment.
Correct.
Infrastructure could be processes, bare metal server, virtual server, or anything else. This is not simply writing scripts, but involves using tested and proven software development practices that are already being used in application deployment and development.
Right.
It lets you make infrastructure changes more easily, rapidly, and reliably.
Okay. So obviously we're looking at different tools for this, correct?
Correct. So there are many different tools available, like we have Ansible, Puppet, Shell, Salt, Terraform, and there are many other available in the market right now. But out of all these tools, Ansible, Puppet and Chef are most commonly used across the organizations.
Okay.
And all these tools basically automates cloud provisioning, configuration management, application deployment, intra-service orchestration and many other IT needs.
Okay, so you obviously mentioned about Ansible first as one of the very widely used tools. Tell us a little more about it.
Definitely, Mark. So Ansible works by connecting to your nodes and pushing out small programs called Ansible modules to them. These programs are basically written to be resource models of the desired state of the system.
Right.
Ansible then execute these models on your host and removes them when finished. Ansible is written in Python and there are more than 200 built-in modules available which we can use.
Wow, okay.
Yeah, and definitely we can write our own custom modules which will basically help us to configure, manage and deploy your infrastructure. Basically your library of modules can reside on any machine.
Correct.
And there are no server daemons or databases required.
Did you say server daemons?
No, daemons and servers.
Okay.
So daemons are nothing but the different threads which basically help us to execute one of the processes. So in the case of Ansible, we don't have any such scenario.
Okay.
It's basically agentless.
Okay.
Yeah. So basically you will work with your favorite terminal program and a version control system just to keep track of your content. And since it uses no agents and no additional custom security infrastructure, it's very easy to deploy. And most importantly, it uses a very simple language called YAML in the form of Ansible playbook, which basically allows you to describe your automation job, which basically approaches the plain English.
Okay. So you mentioned a little while ago that obviously Ansible connects to different hosts. Can you tell us a little more about it? How does it work?
Yes, so Ansible connects to a host using SSH keys with SSH agents.
Okay.
Passwords are supported also.
Correct.
If you want to use Kerberos, that's good too. We have lots of options. And most importantly, root logins are not required. You can log in as any user and then just do su or sudo to any user.
So then how can you tell Ansible about the hosts of the machines that one needs to manage?
So by default, Ansible represents what machine it manages using a very simple inventory file that puts all of your managed machine in groups of your own choosing.
Okay.
To add new machine, there is no additional SSL server signing involved. So there is never any hassle deciding why a particular machine didn't get linked up due to the obscure NTP or DNS issue. It's worth mentioning, Mark, that you can run it from any machine that has Ansible installed on it.
Right.
And it is applied to all the machine as specified in your inventory file.
Okay.
One more thing to note here is Ansible is idempotent as well, which basically ensures that you can run the same configuration multiple times while achieving the same result.
Okay, interesting. Okay, now you've, so that's it about Ansible, right?
Yes.
Okay. You mentioned a little while ago about Chef and Puppet and a few other tools. Do they work very similar to Ansible or?
No, Mark. So all tools work differently.
Okay.
As I have mentioned, Ansible works on a push mechanism, where it basically pushes the different modules to your host or machines which you want to manage, and there are no agent, server or daemons required. You don't even need to install Ansible on every machine you are managing. In case of Puppet, there is a master and agent involved. You need to install Puppet agent on all machines where you require some configuration. And you need to have Puppet master running on a master server which contains all the configuration for different Puppet agent.
Right.
So master basically compiles the configuration for agents, which agent pulls at a specific interval of time by connecting to master. So this specific interval of time is by default 30 minutes, which basically we can override according to our requirement.
Of course.
An agent then checks the configuration it has received against what is really on the machine.
Okay.
And it then tries to fix whatever has changed.
Okay.
So you can see that Puppet works on a pull mechanism instead of push mechanism, where agents are basically pulling the configuration from the master. Puppet is written in Ruby, unlike Ansible, which is written in Python. So these are like major differences between Ansible and Puppet, and definitely there are many different tools are available in the market which basically enabled infrastructure as a code, and each tool work differently.
So how do you decide then what tool do you use?
I would say it entirely depends upon your infrastructure and requirement.
Okay.
Each tool has their own advantages and disadvantages. I will give you a couple of examples. So if there is a need to apply configuration to your infrastructure on an hourly basis,
Right.
then Puppet will be a good option, since Puppet agent can pull the latest configuration at mentioned interval of time, which we just saw. And if you don't want to have any remote management software on the machines you are managing, and you want to make changes to those machines only when a specific change is needed, then Ansible will be a good option in this scenario.
So okay, so let's take a step back and look at it from a very high level perspective.
Okay.
So you've obviously spoken about how this works. Will you say that an organization which is in startup mode or which is 5 people large can use this, or only enterprises can use this, or can this be used across the board?
Okay, so basically there is no restriction on the size of the organization which can use these tools to enable the infrastructure as a code. So even a single person can use it, or even an enterprise with more than 1,000 people can basically use it.
Okay. So you can use it across the board, basically.
Yeah, you can definitely use it across the board.
Okay.
There is no limitation, or I would say size, which basically we take into the consideration while using these tools.
Okay. So then can you encapsulate now the benefits of IaC?
Definitely. So in my opinion, the biggest benefit of infrastructure as a code is to be able to easily and responsibly manage changes to your infrastructure.
Right.
Changes can be made rapidly with low risk. And we can keep doing this even the size and the complexity of the infrastructure grows, and as more teams are using our infrastructure. So infrastructure as code eliminates manual steps to provision, configure, modify and update.
Okay.
So people are able to focus their efforts towards their task, which helps in reducing the cost of an organization.
Right.
Infrastructure automation enables speed through faster execution when configuring your infrastructure, and aims at providing visibility to help other teams across the organization work quickly and efficiently. It also removes the risk associated with human errors like manual configuration, and removing this can definitely decrease the downtime and increase the reliability.
Okay.
So these outcomes and benefits we just talked about can definitely help organization move towards implementing a culture of DevOps.
Okay. So that sounds very interesting, Saptak. Can you tell us, or can you elaborate on the roadmap of DevOps in the sense basically of adoption and usage, etc.?
Definitely, Mark. According to Gartner, which is one of the leading IT research and advisory company which deliver the technology-related insight, tools and technology that support DevOps is expected to grow 21% worldwide.
Okay.
Gartner also expects strong growth opportunity for DevOps in terms of the DevOps tool reaching $2.3 billion by the end of 2016. If we compared it with 2015, it will be like up by around 21% because it was $1.9 billion in 2015.
Okay, interesting.
And by the end of 2016, DevOps will evolve from a niche strategy employed by large cloud providers to a mainstream strategy employed by more than 25% of global 2000 organizations.
Okay, interesting. So, but you mentioned you spoke about DevOps tools. What about IaaC tools?
So IaaC is, as I said before, is one of the most essential DevOps practice. So DevOps is a very vast concept, and to enable DevOps, we need to have different practices in place. Like we talked about infrastructure as code today. We also have continuous integration, continuous deployment, and many other DevOps practices. So just to speak about infrastructure as a code, I would say it will be around 40% of the entire DevOps picture. So you can say of the DevOps pie, it will be a 40%.
40% of $2.3 billion.
Yes.
Okay. Wow, that's a huge number.
Yes.
Okay. Now I have another question for you. You mentioned that organizations of any size can deploy IaaC.
Yes.
Can they do it, or should they be doing it internally, or should they be talking to a service provider like us?
I would definitely encourage to talk to the service providers like us because of a couple of reasons.
Okay.
So in my opinion, if you think about DevOps in a very high level, I would say it is a three-stage conversation between people, processes, and products.
Okay.
So these are the three important P's involved in DevOps.
Interesting.
So DevOps is about people, basically everyone who is involved in delivering value to the organization and to the customer. It is also about the process. Even if you have people, you need to have the processes and practices in place which will enable those people to provide value to the customer. And last but not least, it's about product, tools and services which help enable different DevOps practices.
Okay.
Like in case of infrastructure as code, we saw Ansible, Puppet. Like in case of continuous integration, we have Jenkins, Travis. So for all the different DevOps practices, we have different tools available. So service providers like us have the right people, right processes, and the most importantly, they have expertise in different DevOps tools and services which is already adding value to the customers with whom we are already engaged. So it will definitely going to add value to organization, and it will definitely add value to the customer in sense of that the DevOps can grow in their organization.
Okay. So Saptak has given us an overview of IaC, how it works, and different modules involved in the whole process. We've also learned today that DevOps is growing at a breakneck speed of close to 21%, right, Saptak?
Yes.
So DevOps is the way to go?
Yes, Mark. I think DevOps is the way to go. If you want to grow, if you want to be agile, if you want to be the forerunner in the technology, I think the DevOps is the way to go right now. And it's going to evolve on a daily basis.
Okay, brilliant. So that ends our podcast today. Thanks, Saptak, for your time and enlightening us on a very interesting topic.
Thank you so much, Mark. I had a great time.
Brilliant. So if you have any feedback for us about this podcast or anything else you think we should be talking about, you can write to us at marketing@calsoftinc.com. Thank you and have a great day. Bye.